So this is the Showtime movie theater example again, where X1 is television advertising in thousands of dollars, X2 is newspaper advertising in thousands of dollars, and Y is the weekly gross revenue, also in thousands of dollars. And this was the matrix plot showing all the data, and this is the estimated regression equation with X1 and X2 in the model. Use alpha equal 0.01 to test the hypotheses null hypothesis beta 1 and beta 2 both 0 versus the alternative hypothesis that beta 1 and or beta 2 not equal to 0. We're going to use the mean square for regression, which is 23.435 divided by 2, and the mean square for error, which is 2.065 divided by 5. We're going to use those two numbers to find the F statistic. So we'll take the ratio of those two mean squares for the F statistic, and that comes to 28.38. And then the p-value for 28.38, if we look up an F table with 2 numerator degrees of freedom and 5 denominator degrees of freedom, we find that 13.27 has an upper tail of 0.01, and since the F statistic is larger than 13.27, the p-value must be smaller than 0.01. And we can actually use Minitab to find the p-value exactly, and it comes to 0.002. And so either way, we've discovered that the p-value is smaller than 0.01, which is our significance level. So we reject the null in favor of the alternative and conclude that there is a significant relationship between y and the independent variables or predictors x1 and x2. Next, we're going to use alpha equal 0.05 to test the significance of beta 1 to find out whether x1 should be dropped from the model. So this time our null hypothesis is just that beta 1 equals 0 versus the alternative that beta 1 is not equal to 0. To find the t statistic for this test, we need to find b1, which is 2.290, and then the standard error for b1, which is 0.304, and if we take the ratio of those two numbers, we get the t statistic, which is 7.53, and then to find the p-value associated with 7.53, if we look up a t table with 5 degrees of freedom, 4.032 has an upper tail of 0.005, and 7.53 is larger than 4.032. But remember, this is a two-tailed test, so all we can conclude is that the p-value is smaller than 0.005 times 2. So in other words, the p-value is smaller than 0.01. Again, Minitab gives us that p-value exactly, 0.001. So either way, we've discovered that the p-value is smaller than our significance level alpha, 0.05. So we reject the null in favor of the alternative and conclude that x1 is significant and should not be dropped from the model. And then we'll do the same thing for x2. So this time the t statistic comes to 4.06. And again, we can use a t-table to find that the p-value must be smaller than 0.01, or look at the p-value that Minitab gives us, which is 0.010 to 3 decimal places. Either way, it's smaller than our significance level alpha, so again we reject the null in favor of the alternative and conclude that x2 is significant and should not be dropped from the model.